Hello everyone, we have another question on motion of projectile. Motion of projectile. Projectile is the motion of an object that is thrown or projected or launched into the air and then move under the action of or the influence of what we call gravity. And it will also move, it will describe a curve of trajectory along its path. All right, so now we have this question. A cannon fires a shot at 38 degrees above the horizontal. The initial speed of the cannonball is 70 meters per second. Okay, we have calculate the distance between the cannon and the point where the cannonball lands, given that the two positions are at the same horizontal level. All right, so to be able to calculate the distance, okay, the distance between the cannon and the point where the cannonball lands, given that the two positions are the same horizontal level. So the first thing we need to do is to resolve the velocity, that is the speed, the initial speed of the cannonball, into horizontal and vertical components. That is, now, so step one in this case, step one, resolve the velocity, okay, resolve the velocity into horizontal and vertical components. Okay, so which means the cannon fires a cannonball. Okay, the initial speed of the cannonball is given to be 70 meters per second. So when the cannon fires a shot, okay, the inclination with the horizontal, okay, the inclination with the horizontal is 38 degrees. Okay, so which means when we are to resolve the velocities, we need to consider the velocity along the vertical direction. Okay, that's vertically upward, and that is y on the y-axis. That will be uy, and the velocity along, x-axis, which will be what? ux. So that's why we need to resolve the velocity into horizontal and vertical component. Now when it is horizontal component, now this is ux represents horizontal component of velocity. This represents horizontal component of velocity, and the formula will be u equals to the velocity of projection, okay, cos angle of inclination. Okay, so the angle of inclination is 38 degrees. Okay, now the velocity of projection is what? Is 70 meters per second. So in this case, we have ux to be equals to 70 cos 38 degrees. So let's get the value for horizontal component of velocity. So 70 cos 38 degrees, that will be 55.16. So ux will be 55.16 meters per second. So this is the horizontal component of the velocity. Okay, then also remember I said the first thing, step one, is to resolve the velocity into horizontal and vertical component. So for vertical component, uy represents vertical component of velocity, and we have uy to be the velocity of projection multiplied by sine of angle of projection, and the angle of projection is 38 degrees. Okay, the angle of projection is 38 degrees, so we have uy to be equals to 70 sine 38 degrees in this case. So let's get the value for 70. Okay, 70 sine 38 degrees, that'll be 43.1. So this will be 43.1, okay, meters per second. So this is uy, very important. So this is the vertical component of the velocity of projection, while the horizontal component is ux. Now we want to calculate the distance between the cannon and the point where the cannonball lands, given that the two positions are the same horizontal level. Now we need to manage the space. So what I will do is I'm not going to draw any diagram. Okay, so what we need to do right now is to calculate the time of flight. So the time of flight is the time it takes for the cannonball, okay, to land on the same horizontal level. Yes, to land on the same horizontal level. That is the time for which the cannonball has been what? Projected. That's the time of flight. And we can say that time of flight is the time, it takes for the cannonball, to land on the same horizontal level. Okay, when that's from when it is launched. Okay, so to calculate time of flight, so we then need to consider okay, time of flight. So we're going to consider vertical motion. That is, we're going to consider, so step two is for us to calculate the time of flight. Remember I said time of flight in this case is the time it takes the cannonball to reach the same horizontal level. To reach the same horizontal level. To reach the same horizontal level. So when this occurs, so it means that the vertical displacement or the vertical distance will be equals to what? 0. Even when it comes to how to prove time of flight, okay, of course we have to set the vertical displacement or distance equals to 0, because during time, that's when we talk about time of flight, the vertical displacement will be equals to 0. And in that case, okay, so it means now this occurs, let me put it this way, when the vertical displacement is what? Is 0. So we know that y, which is vertical displacement or vertical distance, is equals to the initial vertical velocity, which represents our that's the vertical component of velocity. So we have uy multiplied by t, which is the time of flight. Now in this case we are considering what? Vertical motion. Now because we are considering vertical motion, so this will be negative, okay, and this will be 1/2 of gt square. 1/2 of gt square. So now, like I said, this occurs when the vertical displacement is 0. Yes, because like I said, the time of flight is the time it takes the cannonball to reach the same horizontal level. So at time of flight, the vertical displacement will be 0. Yes, so which means y, we know that y is the what? Is the vertical displacement. So the vertical displacement will be equals to 0. So we're going to set y equals to 0. So this becomes now uy. We know the value of uy to be 43.1. Remember, we want to calculate the time of flight. So multiply by time t, then minus 1/2 of 9.81 multiplied by what? T square. Multiply by t square. So in this case, we will need to neglect the value of t equals to 0. Yes, in this case, we can just factor out. This will be 0 equals to t open parenthesis 43.1 minus so what is 9.81 divided by 2, 9.81 divided by 2, that would be 4.9, that would be 4.905, then multiply by t. Okay, yes, because here we have a quadratic equation. Okay, so then, you know, of course there will be two values of t, but in this case we need to neglect the value of t equals to 0. So first we know that t will be equals to 0, or 43.1 minus 4.905 t will be equals to 0. So we neglect, so this will be neglected. Okay, this will be neglected. Okay, we neglect that. So in this case, so we only need this one here because the time of flight cannot be 0. So 4.1 minus 43.1 minus 4.905 t equals to 0. So we need to solve for t. So in this case, I'll move this to the other side. This will be 43.1 equals to 4.905 t. So we then divide both sides. Divide both sides by 4.905. So this will be 43.1 divided by 4.905, 4.905 t, then 4.905. So that the value of t, which is the time of flight, okay, we have 43.1 divided by 4.905. Okay, that'll be 8.79. 8.79. Yeah. So 43.1 divided by 4.905. That'll be 83.9 seconds. So this is the time of flight. Okay, so now we now have the value for the time of flight. So we want to calculate the distance between the cannon and the point where the cannonball lands, just like the distance from the point of projection to the point where the cannonball lands on the ground. So that is the range. So the distance, that will be step 3. Step 3 is for us to what? To calculate the distance. Okay, that's distance between the cannon and the point where the cannonball lands. So we have distance between the cannon and the point where it lands, where the cannonball lands, and that will be, distance is x equals to ux multiplied by t. And that's why we needed to calculate ux. So ux multiplied by t. So x will be equals to, so we know that ux is 55.116 meters per second. Now we know that the time of flight is 8.79 seconds. So the distance will then be this guy. So we're using this formula. So 55.16 multiplied by 8.79. And that will be equals to, x equals to 484.9 meters. So this is the distance between the cannon and the point where the cannonball lands, given that the two positions are the same horizontal level. The noblest pleasure is the joy of understanding. Bye-bye.